Well, hello everyone. This is KP the Math G. Yeah, if you noticed before, if I usually wear a cap of some kind, but I didn't choose to wear one this time because hey, I've got hair I don't need to worry about fixing. Okay, I had a haircut, a major haircut at that. My wife is getting used to that, but putting that aside, we have a problem to do here. Coming from the 2008 free response, question number 3. We answered part A in the last video, and we're going to answer parts B and C in this video. It says oil is leaking from a pipeline on the surface of a lake. I hope you can read that, alright. But oil is leaking from a pipeline entering into a lake. The volume increases at a constant rate of 2,000 cubic centimeters per minute. So we know that this is, from last time, that is B at T dt from the last problem. dV over dt. That's what I was thinking about. A recovery device. Alright, now we're talking about removing oil. So oil is going in and oil is coming out. Oil is going in at this rate and oil is coming out at this rate using this expression for this rate, okay? So we want to find the time t when the oil slick reaches a maximum. Now, a maximum volume. Now, we need not to take a derivative or an antiderivative or anything like that. What we want to do is we want to take these rates. So we're saying then that this volume right here now is this rate. This rate here. That's what this is. I'm not just saying V, I'm saying dV over dt, which is a rate. So it'll be this that's going into, so it's into minus removing. Alright, rate into rate removing. Alright, so that's what we're talking about. The rate that the oil is going into the lake and then the rate that it's being removed. And we know that if we look for maximum, remember we want that maximum height where the slope of the tangent line is equal to 0. Alright, so what do we want dV over dt to be? We want it to be max, so we want it to be equal to 0. As a matter of fact, I did a previous video on this very same idea, but we were talking about water in a tank. Water was in a tank, water goes into a tank at a rate, water leaks out of a tank at a rate, and this is the same thing, except this time oil is going into a lake, and then at this rate, and then now they have a removal device that is taking oil out at this rate here. Alright, so let's talk about that. Okay? Now, let's see, we want this to be equal to 0. Rate, alright, into is, well, it's 2,000 cubic centimeters per minute. We won't put the units there on this at this time. So minus 400 times the square root of t. Now that's what you got to realize that you're doing when you're trying to set up these problems. I know what you're going through. I had times saying, how on earth do you set that up? You know, what do you have to do to set this up? And I've had to learn too. Believe me, I've had to learn, and sometimes even relearn a little bit. So things like that, happen, and we just learn it. This rate, which we know if it's a max or even a min, we would have to set this equal to 0. Well, I want to solve this, okay? Let me bring this over on the other side. So plus 400 times the square root of t, 400 plus 400 times the square root of t. Alright, now this is going to be equal to, alright, so now we got 400 on the left side times the square root of t is equal to 2,000. Like that. See what I'm talking about? Alright, there's where we are here. We might can solve it on this side of the board. I don't know. I may have to flip it over, but I'm not sure about that. But here we are. We're looking for a maximum amount here. So here we are. We're going to divide both sides by 400. Alright, there it is. And notice that if we do that, this divides out. We're left with the square root of t is equal to, let's see, let's cross those zeros out. 20 over 4 is 5. But now, to get t, we got to square both sides, don't we? Alright, so squaring both sides, we get t is equal to 25. Alright, and I want to say that's going to be in minutes. Alright, it's going to reach its maximum volume, we're thinking, in 25 minutes. And that's how you set it up. Well, let's make sure we are right about that. Now, let's see. If t is, alright, so in 25 minutes, so we have, let me erase this. I'm going to try to keep this on this side and work the other problem on the other side of the board. Alright, let's see if we can do that. Yeah, I might. I don't think I'm going to need this now. Alright, t is equal to 25 minutes. Alright, t is equal to 25 minutes. Now what we can do is we can start at time 0 to 25 and then go on out greater than 25. So in this interval we're looking at t between 0 and 25, and then here t is greater than 25. And what we're wanting for a max, look at it again. If it's a max, remember we're increasing here to the left of 25, and then of course the slope is 0 at 25. That's the maximum height, right? Which you wouldn't think that we're talking about maximum height, but in this case a maximum here is when it reaches a maximum volume. Alright, then past that it seems like we should be getting a negative answer. So we're looking at the interval t is between 0 and 25, and then t is greater than 25. We don't have a certain, say, well, up to 30 or up to 60 or whatever. Just t is greater than 25. So what do we have? I just erased that, didn't we? Alright, so we had, alright, so we had originally 2,000 minus 400 times the square root of t, didn't we? And we had that equal to dv. Well, we could say equals 0, but yeah, equals 0. Yeah, we do. Oh, in this case, well, let's see. All right, we know it's equal to 0 at 25, but let's examine this and see if this indeed is positive here. We want to see if that is, and negative here. Okay, all right, between our, so we want, that's what we're checking for. If it is, that is certainly a max. If not, if it's the other way around, it's a min, and if both of them are negative or both of them positive, it's neither. Okay, so we are thinking it is a maximum here. So let's plug in some number, some t between 0 and 25. Anything that gives me a perfect square root will work for me. Let's see, I'll tell you what, let's do, I mean, we don't have to have a perfect square root, but it's nice if we do. Let's say instead of picking 25, let's pick something less than 25. Let's say 16. Alright, so 16 is between here, right? Or we could have picked 9 or 4 or 1. Alright, so anything like that. Okay, so the square root of 16 is 4. So 4 times 4. Well, certainly we know that this is positive, isn't it? We don't care what the answer is. We know that the answer is positive because certainly 2,000 is bigger than 16, isn't it? Right. So we do know that does check off that this is positive. If we do something greater than 25, which we can, let's say maybe 36. Alright, so now we got a different story. Let's see. I want to say we do. Let's see, I'm just trying to think. The square root of 36. Let's see, I know it's 6. But now, let's see. Well, it's, you know what, I'm just trying to think a little bit here. Greater than 25. Okay. I'm just trying to think here. Greater than 0. See, greater than 25. Okay. And oh, it's 400 times that. No wonder. Okay, that's what threw me off. It's 400. KP, the math G. Okay, now that was throwing me off. Well, let's try it again. If we tried again 16 here, well, okay, now 16 again. Again, 400 times 4. All right, this is times 4 now, and that's still 1600. So 2,000 minus 1,600. Okay, that is certainly positive, isn't it? Okay. I was wondering what happened there. All right, well, I'm not senile just yet, y'all. Okay. I hope I never get that way. Maybe as long as I'm doing calculus, I won't have to worry about that, becoming senile. Okay. Somebody may say, "Oh, KP." You got another thing coming. Now let's go greater than 25 and let's see what happens. Let's go now to 36 again. Now that's better. This is 6. So this is 2,000 minus 400 times 6. Okay, now we're testing that. That is certainly 2,400 right here. And certainly we know that 2,000 minus 2,400 is negative. And that's what we're checking off right there. So we might say something like this. If you want to, and it does say justify your answer, I don't think you can just leave this like this and say that's enough. You might want to say, well, because you know, they may give you some credit for doing this. Let's see. Let's see. Because dv over dt is greater than 0 on the interval. Okay.
t between 0 and 25, and because dB over dt is less than 0 on the interval, well, it's no interval, at t being greater than 25, then we have a max. Alright. Let's see, a maximum volume at t equals 25. Okay. And then of course 25, t equals 25 minutes maybe. Okay. And that's one way you can say that right there. Okay. Yeah, it reaches its maximum volume 25 minutes after the device begins working. Okay. So that's what you can do here. Because this rate is greater than 0 on the interval, okay, and the rate is less than 0 at this interval, well, not interval, but t is greater than 25. So then we have a maximum volume at t equals 25 minutes. And that's how you explain it. That's how you, I mean, if you want to get that extra point there, you got to be able to say this right here. And how I came up with this, well, that comes through a little study here. Okay, if you get an answer, start at 0 and go to 25, and then if there is nothing that's, you know, if they say, usually some problems say, well, they may just say from 0 to 60. Then you would just say from 25 to 60. You'd find a number somewhere between 25 and 60. But in this case, you don't have an ending number here. You just have numbers beyond 25. Okay, and that's really what you want to do. When is this a max? It reaches a maximum. Okay, all right, and so that's what we're talking about here. All right, that is the second part of the problem. Let's turn this over, and I just wanted to make sure I almost ended the lesson, but let's go ahead. I want to finish this anyway. All right, now then, let's see here. And I didn't write this one down just yet, but it's not very long, so let me go ahead. Okay, it says by the time the recovery, so by the time, okay, the recovery device began removing oil. Alright, I should have had this written down, I apologize. Began removing oil. Okay, there's already, I'm just going to abbreviate this, there's already how do you say that? Yeah, 60,000 cubic, let's do centimeters cubed, okay, of oil already leaked. Well, leaked, let's just say leaked. Alright, it's already out there. That is our initial amount that we already have. And that you'll see that sometimes in problems. So what we want to do, we want to write, all right, let's see, it says do not evaluate, but write an interval, yeah, let's see, an expression, alright, involving an interval that gives the volume of oil. Volume of oil. Okay, I apologize. I should have had this written down. At the time found. In part B. Well, what we found? We found that we do have a maximum at, we said, when t is between 0 and 25, didn't we? Alright, and that's really what you want to look at when you're doing this. So we do know that we have, and it probably won't take long to work. I do apologize for not having this up. I apologize, and I know your time is very valuable. But it says this: by the time the recovery device begins removing oil, already 60,000 cubic centimeters leaked. All right. Now you got to remember also. Let's kind of add to that oil had been coming in. Oil coming in at a rate of 2,000, what was that, cubic centimeters per minute. And remember also that the device, I should have put that down here, well, let's put it over here, device, removal, let's say removal device, I apologize, I should have had this written down. Alright, removal device is given by, okay, it was R at T is equal to, well, let's put it down here, R at T is equal to 400 times the square root of T. Okay, there it is. Alright, we got to have all of this. Okay, I didn't want to have to flip the board over. So we have this. Now, okay, so here's what we got. We have, now this won't take long, 60,000. That's your initial amount right there. Already that's there. You've got that much oil accumulated. That's how much is there. Okay. Now, of course, we have oil coming in, and it's from, we're looking at time t from 0 to 25. Coming in, remember we just already did this, 2,000, okay, minus 400 times the square root of t. Let me erase this part right here. I'm sorry. Okay. All right. And then dt here. And it says do not solve. But that's it. That's what you want to have. Okay. You still want to show how much is going in, and this minus this going out. Okay, you already have this much in there, so it does say write an expression. Alright, and I do think, yes, and that's what we have. They say you get 2 points from this.
setting it up properly, and the proper integrand here. Alright, right here. So anytime you see this, you need to realize that you already have this amount. So that is how much initially you have. It's like if you have water in a tank, and I think one of the problems says you got already, I forget how much water is in a tank. 300 gallons or 3,000 gallons of water is in a tank of some kind, whatever it is. Okay, and then that's what you'll do. You'll do the plus amount of water going in, amount of water going out. Well, this is the amount of oil going in and minus the amount of oil that's being pumped out. Alright, so that is what you do there. And just kind of keep that in mind here. This is important that you understand. You cannot leave this part off. And again, this is already in cubic centimeters. So all of this is volume. This is amount. Okay, that's what you're looking at right there. Alright, and that's, when you see that, I knew that was amount, so I need to make this amount. And remember, when you take an antiderivative of rate, you get amount, don't you? But you gotta compensate, you gotta look for both of these, okay? You gotta keep both of these in mind, and that's why I had to add this up to it when I put these up there just a while ago. Okay. Alright, there it is right there. And again, I do apologize. So what do we do? Just kind of make sure we understand. Okay, so we had to have this answer to be able to do the next one. That's sometimes the way it works on these tests. Alright, so we had to realize that we had to set these, well, we had to set it 2,000 minus 400 times the square root of t equal to 0. We had to do that first, and we found that t was equal to 25, and we found that out by testing it. Okay, and then we did find it, but and made that conclusion. You can come up with that conclusion on the first part, and on the second part you use this right here to find, just set it up. You don't have to do any solving, and I'm kind of glad of that, because you're on a timed, you're taking a timed test, so, and I think they realize that too. Okay, anyway, I hope that has helped you out, and I do appreciate so much your patience with this second problem. I thought I would have to put some of the first problem on this side of the board, so I kind of refrained from writing this out right away, but anyway, I appreciate your patience with me on that regard. Anyway, if you will, you can subscribe if you haven't already, and you can, if you have already subscribed, keep on watching if you'd like to. I hope you do. I hope this is encouraging you to keep watching these videos, and this is helping you out. Please also hit that like button. I like those. And of course, again, like I always say, if you don't like it, you can say I didn't like it, but give me a comment and say what I could have done better, or what you didn't like about it. Okay. So anyway, I do appreciate you very much, and I do appreciate your patience, and I do not take that for granted at all. I appreciate everyone tuning in. Anyway, KP the Math G signing off. You folks have a great day. Sign off with that signature clap. Here we go. 1, 2, 3. There it is.